All right, so let's take a look at a couple of examples of graphing parabolas in vertex form. So the reason why we call this vertex form is because this equation, so this x minus 2 actually tells us the x coordinate of the vertex, and it's positive 2. So it's always the opposite sign of there. Okay, so x minus 2 squared is going to have a vertex at where x is positive 2. And then this number is actually the y value. Okay, so it moves the graph 2 to the right, so positive 2, and then 3 down, so negative 3. So I have a vertex at 2, negative 3, which is right there. Okay, the opponent of the graph, so because there's no negative here, it's positive, so that means it's going to open up. And then this number here is what we call the step multiplier. So it's 2. That'll come in handy in a second. Okay? Now what we're going to do is we're going to use a table of values to graph this thing. So the reason why it's important to know the vertex is because that is going to be the middle of my table. And so now I want to see what's happening to the left of the vertex. So to the left of 2 is 1 and then 0, and to the right of the vertex, so 3 and then 4. So those x values are always going to change based on the vertex. Okay? All right, and now to find the y value, I'm just going to sub in x values. So y is equal to 2, x minus 2, so 0 minus 2 squared minus 3. So we can put all that in our calculator, or we can go step by step. And so we get 5. So that means when x is 0, y is 5. So there's a point right there. Okay? So let's move that out of the way. And then we'll do the next one. So when x is 1, 2 times 1 minus 2 squared minus 3. So 1 minus 2 is 1, squared is 1. Minus 3, that gives me negative 1. So when x is 1, y is negative 1. Okay, so there's my vertex. Now, because I know what parabolas look like, I actually know that this parabola goes down to the vertex like this, and then it's going to go back up. Okay, but let's check using our table of values. So we'll do the right side. So y is 2 times 3 minus 2 squared minus 3. So 2 times 1 minus 3, negative 1. See? Matches. Okay? Now let's do the last one. So 2 times 4 minus 2 squared minus 3. 2 times 4 is 8, minus 3 is 5. So I have two other points, 3, negative 1, and then 4, 5. So 4, 5. So you see how that just, like those match? So that's always going to happen if my table of values was done properly. Okay? So there's my graph. Okay? Let's look at one more. Okay, so my vertex here, again, 2 to the right, so x is 2, and then the y value out here, there's nothing. That means the y is 0 because it hasn't moved up or down. This is opening down because it has a negative there, and the step multiplier is 0.5, okay? All right, so my vertex, again, I'm going to center it at 0, at 2, because that's what the x value is, y is 0. And then to the right is 3 and 4, and to the left is 1 and 0. Okay? So I'm going to sub in x is 0. So negative 0.5, 0 minus 2 squared. That's negative 0.5 times 4, which is negative 2. So 0, negative 2. Oh, and I forgot to plot my vertex. 2, 0. 2, 0. Okay? So let's do this next one. Negative 0.5, 1 minus 2 squared. Negative 0.5 times 1, that's negative 0.5. So that means at 1, it's negative 0.5. Okay, I'm going to do this next one. Negative 0.5 times 3 minus 2 squared. I calculate that, it's negative 0.5. So 3 is negative 0.5, and this last one, negative 0.5, 4 minus 2 squared is negative 0.5 times 4, which is negative 2. Okay, so again, I'm seeing that my parabola is symmetric. It opens down just like I predicted, so that's good news. That's how we graph parabolas using a table of values.